Now we need to write a script to handle the data once it's input by the user into our feedback form and sent to our send feedback PHP script. Let's open up a new text file and we'll save that as send underscore feedback.php. We're going to start this script the same way as we did with the others, with a title and a header, so that we can return some kind of HTML page to the user once the data has been successfully added to the database, or unsuccessfully as the case may be. For a start, we need to check that all the data is there. Let's use a simple if statement, and this checks for empty variables. These logical not operators will say that if this field is empty, then this part of the statement will return true. And we separate each part of the expression with logical OR operators. So if any of the fields are empty, then this if condition will be carried out. Now we're not going to include the spam variable, which can either be set to 1 or 0, because in PHP the 0 value is the same as, in terms of the if statement, will read the same way as an empty field. Both of them will return false when the variable is evaluated. That will mean that if the user decides not to be sent any feedback, then if we added the condition like this, then the PHP script will treat it as if one of the fields was empty. Now, luckily, we don't have to worry about the workaround for that at the moment, because our database is set up so that if the field is not delivered, then it automatically fills in a 0 value for the spam variable. We need an error message that the user will see if they fail to fill in all the fields. And we can show this within our PHP script one of two ways. We need a hyperlink at the end here to send the user back to the feedback entry page so that they can try again. Now, we could echo all of this on one line, or on several lines if we wanted to split it up. But another way of doing it is to simply use an closing tag here and include all this text simply outside that part of our script. So in effect we create a little kind of landlocked piece of HTML, and then we go back into our PHP script with another of our PHP tags. Now, this is a matter of personal choice, and it depends very much on what kind of text we want to echo to the browser. If it's just a couple of words, it makes much more sense to use an echo or print command. If it's several lines like this, then we might find it clearer and easier to break out of our PHP script for a moment and then go back into it. It works in exactly the same way, however, and this text will only be output if this condition is true. So the next thing we need to do is to have an exit command so that if this condition is true, then the rest of the script will not execute, and we need to close that curly bracket that encloses that block of commands. Next, we're going to use a command called add slashes, and what this does is if the user happens to, within their script, within their input rather, add some character like quote mark, then when we come to evaluate that variable and use it within our SQL script, we could find some complications arising. So what we're going to do is use our add slashes command on each of these variables, and what that'll do is it'll just add a little escape character before any problematic characters that it could encounter, such as quote mark. So that all three fields have been put through that process, and now we need to make a connection to our database as before, and there we're going to select the correct database, Vinyl Dealers database, and then we're going to set up a SQL string. We're going to call this one add feedback. We could call it query as we normally do, but just to make it very clear what we're doing with our piece of SQL, we're going to use this format. What we're going to say is we're going to insert into the feedback table, and we're going to specify each of the fields. This is because within the structure of our feedback table there is an initial field which simply stores the ID number, which is going to make each piece of feedback have a unique identifier. So basically we don't want the username being put, or MySQL attempting and failing to put the username into an inappropriate field, such as the ID field. And we're going to have to use single quotes to surround our variable names, and we can either put them in very simply like this, which may seem like a very easy way of working, or we can do it the slightly harder way of including a close quote and a concatenation symbol either side of every variable. Now this may look like it's just adding a few extra keystrokes and extra work to what should be a simple operation, but with some configurations of PHP you may find that the facility that allows you to simply put variables into a string and for them to be evaluated has been disabled for greater efficiency. If you come across that, then that could cause some problems for you. So, for the sake of being able to deal with any kind of PHP setup, we're going to include all the double quotes and concatenation symbols. Next, we're going to run that query just like all the other queries we've worked with before. And then we're going to close out PHP script again, and we're going to put on a little message at the end to let the user know that their data has been successfully added to our database. Now there's no error checking as yet to make sure that really has been added to the database. We'll look at that in a later chapter, because that's a whole other can of worms. So there is our script. Let's save that. And we would, if this was for a real site, add some kind of link after this comment here to take the user back to the home page. There's no home page though in our sample setup, so we're not going to do that. Now I've added some data here to our feedback form, and as we can see, I've included one of the potential problem characters, this single quote, and our add slashes function should pick that up and deal with it anyway. So we're going to submit that data, and apparently our comments have been added to the database. Let's take a quick look at the MySQL monitor, and we'll see whether that's worked. As we can see, our latest piece of data has been added here. These other two fields are from earlier on when I was testing that PHP script. So as we can see, our piece of data has been successfully added to the database. In our send feedback script, we have one very simple piece of input validation, and that is we validate each of these fields for some data. So we make sure that none of the fields are empty. However, there is another very simple thing that we can test for, and that's to test that the user has put in a valid email address. Now we have no way of telling that the user has put in their email address, and we certainly can't see whether the user's email address actually exists as a real valid address that mail will go to. But we can test to make sure that the email address is the right format, which will prevent people from just putting in a few random letters and numbers and thinking that they can add their data to the system without giving the data that we've asked them for. So let's include a very simple condition straight after this condition, and what we're going to use to test for the email's validity in format is we're going to use a regular expression which is going to test to make sure that it fits the right pattern that an email should look like. Now we know basically what that is intuitively through having seen a lot of emails addresses, and that will be, there'll be some text of some kind, and then an @ sign, and then a domain, which will be some text with maybe a .com or a .net, or for a more local one maybe it'll be .com.au or .de. Now we can specify that in a very specific way using only one line of code, using a regular expression. This is a very good example of the flexibility and power of regular expressions in a real situation. We're going to use this function, and you notice that we've included the I at the end of the function. This makes the test case insensitive, so that it won't care whether we're talking about capital letters or small letters. Now, the syntax for our email testing is going to be something like this. We're going to use that symbol, which in the case of regular expression syntax is going to stand for at the beginning of the string that we're going to test against. So at the beginning of the string that we're going to test against, it wants to find the following character pattern. And the first character has to be a letter or a number or an underscore character. And then we include those within square brackets so that PHP knows that we're looking for something within one of the two ranges we've specified or the underscore character. Then we're going to use a plus symbol, and this means one or more of this kind of character. Then we need the @ every email address has an @ sign, and that's just treated as a literal @ sign. And then we need to do something similar here, except that we need to include a hyphen character, and we're going to use a backslash before it in order to escape that particular character. And then we're going to use a plus sign to say that we need one or more of this kind of character, and then we need a dot. We're going to have to use the backslash again to escape that, because the dot has another particular significance within regular expressions that at the moment we don't mean. We just mean a literal dot. Then a number of letters or numbers or hyphens or dots, because there could be more than one dot included within the domain, for instance in the case of a local domain name such as ihug.com.au. And then we need another plus sign to indicate there can be one or more of those kind of characters. Then we need a $sign at the end to say that nothing else will come after that last particular pattern. To say that we expect the string in its entirety to fit that kind of a pattern. And then we need to give the name of the string that we're going to check against this regular expression. And as you can see, we've put the logical not operator right at the beginning. So what this condition is essentially evaluating is if email, the variable email, is not a valid email address according to this pattern. Then we're going to have to include an error message similar to the one above. So we're going to have the same heading, and we're going to need a different error message, however, so that the user knows what they've done wrong. And then we're simply going to use we're going to reopen our PHP tag rather, and we're going to have an exit statement, and then we're going to close that curly bracket to close this block of commands. Now we're going to save our script. Now you'll notice that there's some repetition here. We've repeated this kind of code with this kind of thing here. Because there's two separate pieces there, we can't just use a single variable and drop that variable in whenever there's an error. Now you may be thinking that this can't be an efficient way to do things, and there must be a way to code this kind of situation without repeating text. And you'd be absolutely right. Repeating things in our scripts is Not always, but in the vast majority of cases, if we find ourselves repeating any code, then we're doing something wrong. And we're going to learn in our next chapter about functions and a way to automate this kind of error capture process. But right now, we're going to leave it like this because this works with the techniques that you've learned so far. Let's go back to our browser and we're going to test. First of all, we're going to test leaving the email blank. Please fill in all fields is the error condition that we get. So let's go back. And now we're going to try putting in just some random text, not an email address at all. As we can see, our PHP script has asked us for a valid email address. So it's correctly identifying invalid email addresses. And we need to put in an extra line break here for the sake of neatness. So we've installed a very simple little error capture system, which is not going to capture all errors, but is going to go a small way towards making our system a little more robust. In our next movie, we're going to look at file uploads. Before we look at the techniques by which we can allow a user to upload a file to our web server, it's important that you realize that it's not a good idea to allow any user, any old user, to load any file to your web server. I recommend that you wait before you implement any kind of file upload system until you've become very familiar with the security and authentication systems, which are going to be detailed later in this title. However, it's worthwhile learning how to implement a file upload even if you're not going to put it into practice straight away. To begin with, let's create an HTML form where the user can submit a file for uploading. And we're going to call this upload. And we need, in our form, we need as the first attribute within the form tag is going to be enc type, and we want to specify multipart / form - data. In the name of the action attribute, we want to include the file name of the PHP script, in this case uploadfile.php. And we need to specify that the method is post. This won't work if the method is get. Now we need an input of type hidden, and what this is a way of including an extra piece of data without the file that we're sending, and that is max_file_size, and as you may be able to guess, that specifies an upper limit on the size of the file that the user can send. Let's say we specify 20,000, which is just under 20k, and then we're going to write the word file name, and we're going to say input name equals user file, type equals file, and that's going to be the field from which the file is sent. Then we're going to need 2 line breaks. Now, because we have an input of type file, your browser will automatically add a browse button so that the user can locate the file on their hard disk. The final control that we need in our form is going to be a submit button. and we're going to call that send. We can close the form tag, the body tag, and the HTML tag, and we can save that file. We're going to save that as submit file.html. And now let's open a new text file, and this is going to be the PHP script which will handle the file once it's submitted from the HTML page. And we're going to call that upload_file.php. And we should make sure that that tallies with what we've written here. And then we're going to write our PHP script. To save time, I'm not going to bother to format this as an HTML page, because all it's going to be doing for the moment is producing either an error message or a success message. First of all, we need this condition, which will check to see if a file has really been sent from the HTML page. If the user does not specify a file, then the user file will be set to variable will be set to none. Now, as well as the user file variable, another set of variables are also automatically passed on by the HTML page. And these are user file name, and this is the name under which the user file appears on the user's computer, on their hard disk. And then the size, which of course is the size of the user file. These variables are automatically generated when the HTML page submits the data, which is why you can't see the place where they came from. User file type, that will specify if it's text type or a JPEG or what kind of type the file is. But at the moment we're just dealing with the user file variable, and if none is sent, then this value is automatically generated. We give an error message here and say no file specified and exit. Then we're going to use a command called move uploaded file. This is a PHP function which allows us to send the user file to a place that we specify in the second argument. And this we're going to specify a directory, and preferably this should be outside of your directory, of your web server root directory. So if we take a look on our hard disk here, I've created a directory called uploads, and that's just simply off the root of C. That's not within our document root where we've been putting everything else here. So we're simply going to put the files into this uploads directory. How we specify that is backslash to specify the root, and we'll need 2 backslashes because to make sure that the backslash is interpreted correctly rather than just the escape character, which is what PHP will assume it means. And we're going to put in the name of the directory there. I should add that we're using 2 backslashes because we're running this on a Windows machine. If we were to run this on a Unix machine, we'd be using a single /. So there's the directory, and then we put the original name that the file had when it was submitted. Now, at the moment, this is simply a command or statement. However, we can check that this has been correctly carried out by enclosing it within an if condition. Now, since every function or every statement in PHP evaluates either false or true or some other value, this one is no exception. This one will evaluate true if the file is moved successfully, and will evaluate false if it's not. So we can put another couple of messages in here. With an else statement to make sure that the file has been moved correctly. So, let's save our file and we'll try that out in the browser. And our file was called submitfile.html. And here is our upload page. Now if we browse for, let's find some text file of some kind. Let's say we use this password file. And as the user, we're going to send our file to the web server. Your file has been uploaded, it tells us. Now let's take a look and make sure that's really been sent. We'll have a look at uploads, and sure enough, the file that we selected has been moved by PHP to the folder we specified. I'm going to have to end this movie again by repeating my caution that file uploads should only be allowed once we're satisfied that, first of all, the user is someone that we trust, and also we should make very sure about where the files are going. In this chapter, we're going to look at ways to make our scripts more efficient, ways to reuse elements that we've already written, and to avoid redundancy. To do that, we're going to be looking at PHP functions. And that's both the inbuilt functions that are included within PHP and custom functions that we can write ourselves to suit our individual needs. We're also going to be looking at variable scope in the context of functions and ways to pass arguments either by value or by reference to our functions. We're also going to be looking at variable numbers of arguments and the kind of functions that can deal with such a procedure. And we're going to be writing recursive functions which can actually call themselves. We're also going to look at date and time functions. Another thing we're going to cover in this chapter is external scripts, which we can use to reuse elements of code and keep different reusable packets of code separate from each other. We're also going to look at error capture, ways to deal with the inevitable moments when things go wrong with our PHP scripts. Now, to begin with, let's take a look at some simple functions within PHP. We've actually already seen quite a few functions, such as the string function strReplace, such as the database function MySQL connect. We use functions for quite a lot of things that we've done up till now, and although they all do very different things, they all follow a very similar syntax, and that is function name, then a bracket which can take any number of arguments separated by commas. And those arguments can be, say, a number or a string, or they can even be a variable. Let's take a look at an example first. Before we get into functions, we're going to take a look at scripts written without functions and the reasons why we need to use functions. Let's say we wanted to convert a temperature from Fahrenheit to Celsius. Start out with a temp function, a temp variable, I beg your pardon, called temp, and we're going to give as the value 80. Then we're going to say converted is going to be temp minus 32 multiplied by 5 and divide by 9. And then we're going to echo converted to the browser. Let's take a look at that in our browser and make sure that works. As we can see, the number 26.6 recurring is the product of our conversion. However, what if we wanted to convert more than one number within our script? Maybe we could keep all three of those lines and then copy them, paste them down to here, and simply change this figure. Let's say we took 212, and we're going to put in an extra line break in between those two. I'm just using these line spaces here to split up the script and make it easier to see what we're doing. There's no particular reason or significance behind those line spaces beyond that. If we go to our browser again and refresh, we can see that the conversion has been done on two different numbers this time by our script. And we know that the conversion's working correctly because 212 Fahrenheit is 100 Celsius. So that's a good test for our converting equation here. However, there is something very wrong with this script, even though it works. These lines are exactly the same, and they're repeated within the script. Now that may not be so much of a problem when we have a script with a total of a very few number of lines, around 12 lines, but as our scripts get more complicated, we'll find that anytime we repeat something, even if it's just a line or a couple of lines, that's a kind of a warning sign. That means that we've somehow been wasteful in our techniques. We've somehow allowed a redundancy to creep in, and we've repeated something that we could have automated. Because that's, after all, what computers are about. They're about finding ways to take the donkey work out of calculations. We shouldn't have to do anything twice. Even if it's just typing a line of code twice, we shouldn't ever be typing the same line of code exactly twice within a program. That's a good rule of thumb. There are some exceptions, very, very rare cases, but that's a great rule of thumb to see whether what we're doing is redundant or not. So, how do we get around this problem? Let's take these lines out. And what we're going to do in order to replace them is to use a function. And how we define our own function is we use this syntax. We use the keyword function, and then we give our function a name. This can be whatever we want. So let's call it F to C. Fahrenheit to Celsius. It's a converter. And we're going to have it store one variable as an argument, and that's going to be included within these round brackets here. Then we're going to have these curly brackets, just like an if statement or a for loop, that encloses the block of code that follows the function definition. And this, whatever we type in here, is what the function will do. So in this case, we're going to define a variable c, and we're going to set it to f minus 32 times 5 divided by 9. And then we're going to use the return command, return c. So essentially, what this does is any time we call this function, f to c, it'll do this, and it'll put whatever we put after the return command in the place of the function that we include within the script. That may be a little confusing. So let's start out with a very simple function, and we're going to call it squeak, and it's going to take no arguments, and all it's going to do is return the word squeak. Actually, let's not use squeak, let's use something onomatopoeic like ee. Okay, now you may be able to guess what this is doing, but I just want to spell out exactly what a function does. We say echo, and then we type in the function name. PHP will arrive at the function name, squeak, and replace it with whatever we've said after return. This is known as a return function. So if we carry out that script, as we can see, it's echoed E to the browser. So we can see basically what's going on with this function. Another thing to note is that the function doesn't have to be defined before we call it. That's why it's a good idea to put our functions right down the bottom of the script, where they're out of the way. This is a new feature as of PHP 4. Now, let's use our Fahrenheit to Celsius converter. Now that we can see how a return function swaps whatever we put after the return command for the function name included in the script. And all we're going to do is we're going to say echo f to c 212. Then we're going to put in a line break, and we're going to say echo f to c 67. We'll save that, and we'll pop back to our browser. As we can see, two figures are given based on two conversions, but we haven't had to write this code twice. All we've had to write twice is the name of our function. So, as we can see, although this is a very simple example, we could automate as much code as we wanted within this code block and save ourselves a lot of hassle further on down the road. One thing to be very careful of when we're working with functions is to make sure that we've scoped all our variables correctly and that they're doing what they think we're going to do. What variable scope means is that each variable that we declare within our script has a specific scope from which it is accessible and from which we can make changes to its value. For instance, a variable that we declare inside a function is not going to be accessible from outside that function, and a variable that we declare outside the function is not going to be accessible from within it. Let's take a look at an example to see the way this works. First of all, we'll just set a variable, let's call it number, and we're going to set it to the value of 4. And then we're going to echo that to the browser like this. I'm going to put a line break in there as well. And then we're going to set up a function at the end of our script. And let's call this function myfunc. We don't need to give it a particularly useful name because we're only going to be using it to exemplify the way variable scope works. We've got no arguments, so we simply open those round brackets and close them again. Then we use curly brackets to demarcate the block of text that's going to represent what the function does. What the function is going to do in this case is going to set a variable called number, and we're going to set the value of that to 10. Then we're going to echo within the function the value is, and then we're going to put number, and again a line break. That's our function, and that's the end of our script. Now we're going to call the function from here, simply like that. Now, as we noted in the previous movie, it doesn't matter where we declare our function, we can call the function. So long as we declare the function somewhere in the script, we can call it wherever we like. So it's quite acceptable to have the function declared right at the end of our script. And in fact, that's a clearer way of working because it keeps those functions out of the way of the script, the flow of the main part of the script. Finally, we're going to have a last echo statement, and that's going to say a very similar thing to the previous ones. Basically, all these do is echo the number and a little reference so that we know from what part of the script that's being transmitted. Let's take a look in our browser. Now, as we can see, at the beginning of the script, we get the value 4. The second time it's echoed from within the function, the value 10 is given, and at the end, the value 4 is given. Let's take a look back here, and we'll see that this line has produced the output 4, this line produces the output 10, and when we call the number variable a third time, the value 4 is given again. Now, intuitively, we may think that since we set this variable here, once myfunc is processed, then this line should also give the result 10. However, it doesn't. It gives 4, and the reason for that is that these two variables, number that's declared out here and number that's declared within the function, are in fact two entirely separate variables. It is quite possible to use variables with the same name inside and outside of functions and have them doing completely different things. It is a good idea to, as much as possible, avoid that kind of thing, simply to make sure it's easy to, at a glance, looking at your script, see what a particular variable is supposed to be doing and which variable is which. However, because of variable scope, we can see that these variables are kept entirely separate. Now, the exception to this rule is if we specifically declare within our function that a variable should be global. And this is the way we do it. We use the global keyword and then we specify the number there. Let's take a look. If we save that and go back to our browser, what happens here? As we can see, the function has now altered not only the effect of the variable within itself, the number variable, but also the variable outside. In effect, by saying this, we're effectively referring to this number, this variable as well, and any other variable number that we could use within a different function. We're going to take a little more look at the use of variables within functions in our next movie.